Alright, so in this video I'm going to do 4 examples of taking derivatives with respect to time of different functions. So for this first one, we're looking at taking the derivative of z with respect to time, and z is equal to cos theta. Now we're told that both z and theta are dependent on time. So in order to do this one, we need to apply the chain rule. So that means that we can say that dz on dt is equal to dz on d theta. Okay, so the derivative of this one multiplied by then the derivative of theta with respect to time. Okay, and you can see that what happens there is essentially we have d theta cancelling out on top and bottom lines. So all that we're left with is the derivative with respect to z. So let's go ahead and apply this. So the derivative of z with respect to time, you can either write it as dz on dt, or it's the same as calling it z dot. Alright, so now we need to take the derivative of z with respect to theta. So it's essentially just taking the derivative of this since it's equal to z. So cos goes to negative sign when you take the derivative, so it's going to be negative sine theta. We then need to take the derivative of theta with respect to time since they're dependent. So the derivative of theta with respect to time is just going to be either d theta on dt, or you can write this as theta dot. So the answer becomes this. Okay, so that's the first example complete. Of course, there we needed to use the chain rule. That's what this is called in here. So let's do another example. Alright, so for this one we have z is equal to x cubed plus 2x squared, and we're told that both z and x are functions of time. So again, we're going to need to use the chain rule in order to evaluate this. So dz on dt is going to be equal to the derivative of z with respect to x, so essentially the derivative as you would normally do it for this equation, but then because x is dependent on time, we've also got this dx on dt in here. So you see that the dx essentially cancel out with each other, and we're left with dz on dt, which is, what we want to find. So the derivative of z with respect to time is either dz on dt or z dot. We then need to take the derivative of this equation with respect to x. So this is where you apply your rule for the polynomials, where you take the top number and you multiply by the one in front. So there's a 1 in front, so it'll be 3 times 1. Write down your variable and then take 1 off the power. So that's going to be 3 take 1 is 2. So then we add on, we need to do the same rule, so it's going to be the 2 up the front multiplied by the 2 down the front, gives us 4. Write down the variable and take 1 off the power, so 2 take 1 is 1. So this is the first part of our equation. Now we just need the derivative of x with respect to time. So for this, we can either write it as dx on dt, or it's the same thing as writing it as x dot. Okay, so the final answer for this question, writing it a little bit neatly, would be 3x dot x squared plus 4x dot x. So that's all we've got there. So we've got 2 examples left to complete. These ones are a little bit more complicated from now on because they're going to involve the product rule. So if we scroll down, I left it off the end. So again, we've got things that are dependent on time. So we're going to treat z, x, and theta as functions of time, and therefore they're going to have time derivatives. So for this one, because we have 2 things that are multiplied together, which are functions of time, we're going to need to use the product rule. So the product rule as it's normally written is that if you have y is equal to u times v, then your derivative, I'll write it as y dash, is equal to uv dash plus vu dash. Okay, so that's the product rule. And we're going to need to apply it. So, let's start with z. So we know that z is a function of time. So when we take the derivative of it, we know that it's going to be dz on dt, or you can write that as z dot. Alright, so moving on to here, we're going to end up needing to treat this with the product rule. So I'm going to call this part of the equation the x squared part. That's going to be u. And the sine theta is going to be the v part of the equation when we apply it. So, applying this equation, u is x squared, okay, and we need to multiply it by the derivative of v, which is the derivative of sine theta. So this is going to require the chain rule again. So basically, if you want a shortcut having to write out the rule, you just take the derivative with respect to the thing in the equation, in this case theta, and then multiply with respect to that the derivative with respect to time of that variable. So for this case, the derivative of sine theta with respect to theta would be cos theta. Sine goes to cos. And then we need to multiply it by the derivative of theta with respect to time, since we know they're dependent. So theta with respect to time is d theta dt, or you can write that just as theta dot. Alright, so now we just need to do the second part of the equation. So for that we hold v constant, so it's just going to be sine theta. And then we need to multiply by the derivative of u. Okay, so that's the x squared. So again, if you want to, you can write out the chain rule in full, like I did in the first two examples, or you can just shortcut it a bit. So it's going to be the derivative with respect to x, and then multiply it by the derivative of x with respect to time. So it's going to be 2 x to the power of 1 for the derivative with respect to x, and then we know x is a function of time, so that's the same as x dot for its derivative. So if we write this out a little bit neater, we're going to get that z dot is equal to x squared theta dot cos theta plus, let's write this as 2x x dot, oops, sine theta on the end. So that's the answer to that one there. Alright, so we have one more example left, which is going to require the product rule. So this time I've thrown in a couple of constants to make it a little more tricky. So this time we know that y is a function of time, x is a function of time, theta is a function of time. However, we have two constants in the equation, a and c, which are not dependent on time. Makes it a little bit more tricky. So we need to take the derivative with respect to time. If we start with the left-hand side, the derivative of y with respect to time is going to be dy dt, or equally you can write this as y dot. Alright, so next we have to deal with this term, which is a little bit messy, and a is not a function of time, so it's just like it was a number sitting in the equation. X we know is a function of time, and theta is a function of time. So unfortunately we're going to need to apply the product rule on this, because we have two things multiplied together. So I'm going to treat this as u, and this is v, in the product rule. So remember that for the product rule, it's uv dash plus vu dash. So for the first bit, we hold this the same, and take the derivative of the second part. Again, if you want to write the chain rule out in full, you can. Otherwise, it's going to be the derivative with respect to theta, and then the derivative with respect to time. So first bit, derivative of cos is negative sine. And then we need to multiply by the derivative of theta with respect to time, which is theta dot. Then we've got to add on v when our holding constant, so cos theta, and we need to multiply by the derivative of u, which is u dash. So in this case, a is constant, remember, so the derivative of this is just going to be a, alright, applying your regular rule for the polynomials. Alright, so now we've covered off this term for its derivative, we just need to work on this second one. And remember that c is a constant. It's just like we had a number sitting out the front. So, the derivative of this, we're not going to need to use the product rule for, because we don't have two things that are dependent on time multiplied together. We can just jump straight in. So, c is a constant that stays out the front. The derivative of sine goes to cos. and we need to multiply by the derivative of theta with respect to time, which is theta dot. Alright, so let's write this out a little bit nicer. So we're going to get y dot is equal to negative ax theta dot sine theta plus a cos theta, and then plus c theta dot cos theta. And that's the answer in there. So hopefully those couple of examples will help you with taking these derivatives with respect to time. Really the only trick is making sure you recognize when you need to use the product rule, when you need to use the chain rule, and when you have constants in the equation. So I've covered off on a few examples of each of those, and there's going to be some applied examples in the other videos. So that's all there is for this one, and see you in those.